Okay, so trig, we're in 1.4 continued. We call this the chart. So once upon a time, you memorized things like 3 times 4 is 12. And it seemed like a challenge at the time, but you eventually got those timetables ironed out. I'm going to suggest you memorize some answers to sine, cosine, and tangent for certain common angles. Yesterday we drew up in the notes the special triangles, and we generated a bunch of answers from those that involved 1s, 2s, roots 2s, roots 3s. I did a 0 note and a 90 note. So that's all sort of going to get the special triangles, and that 0 and 90 notes are kind of just going to get incorporated into this little chart. So 0 degrees is a common reference angle you'll be seeing. 30, 45, 60, 90, those are the superstars. And then just try to memorize these numbers. 0, half, root 2 over 2, root 3 over 2, and 1 go in that order. The sine column starts low and just goes up. So the book makes a suggestion. You could think of this as square root of 0, which is square root of 0 makes 0. So this is like the square root of 0 over 2, the square root of 1 over 2, the square root of 2 over 2, the square root of 3 over 2, and the square root of 4 over 2. That might make some semblance of a pattern for you, because the square root of 4 is 2, which if you put it over 2 is 1. Square root of 1 is 1, put it over 2. So they suggest just thinking of square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, and square root of 4 over 2 in a little pattern. You just make some of them better. But eventually, it'd be better if you just said to me, and I could say to you, like sine of 30, and you're like, that's a half. Sine of 60, it's root 3 over 2. Just, we don't need to look it up for the rest of our lives, maybe. If you get the sine column mastered, the cosine column is very easy. Why? It's reversed. It's the same numbers, just in reverse order. Instead of 0 up to 1, it's going from 1 down to 0 in the same order. If you forget tan, you can always figure out tan by doing sine dividing cosine. Sine divided cosine for any certain number can always make tan. So if you can't memorize these, just build them. 0 divided by 1 is 0. Anything dividing itself
Is 1.
is 1. Things trying to divide by 0 are not allowed. If this divides this, what's going to happen to this?
Flip.
Let's flip. Who can cancel them? 2's. Temporary answer? 1 over root 3. Fixable? And then this, same game, flip the second one, cancel 2's, permanent answer immediately available, root 3. If you know where it came from, great. It came from the special triangles, but if you just memorize it from here, you don't really need to ever look at the special triangles again. So if the special triangles were making you mad last night, they don't matter anymore. This replaced them. If you like them, they still work. It's fun. The other question we have is what's positive where? So I draw this little diagram to describe who's positive where. The A stands for all of them are positive in quadrant 1. Because we're going right, we're going up, everything's positive over there. Only sine is positive in this quadrant out of the main 3. Who's linked with sine though? If we flip sine, who do we get?
Cosine.
Not quite.
CSC.
CSC. What's CSC stand for? Cosecant. Flipping sine is positive, therefore so is cosecant. But of the big 3, sine is positive only in quadrant 2. Since we went left, there would be negatives on some other ones. T stands then obviously for tangent, and therefore its flipped friend. COT stands for cotangent. And then the C must stand for cosine. And its flipped friend Abby likes the abbreviations better. SEC, true, stands for
Secant?
secant. Tomorrow, I'll give you a quiz by handing you a piece of paper that looks about like this and say, do the chart. Okay? And what I have in mind when I say do the chart is to do this as well as the what's positive where. So I'm figuring 15 points for the answers in their slots. 1 point for just the structure itself is 16, plus 4 of those gets us to 20. So once upon a time, there was a person who was sort of like a legendary student. She had 100% on like everything. When we did the first Trig do the chart quiz, she did this and forgot to do this and got 16 out of 20. I don't know if she ever missed 4 points on the same paper in her life ever, but she was temporary in last place for like till the next paper came, and then she crushed everyone like a bug eventually, like she always did. But don't forget this. This and this together is do the chart. Question about the do the chart. So then here's how this comes into play. If I ask you to do the sine of 135, you need to either draw or imagine, eventually preferably imagine because it's just quicker, where 135 would go. Where does 135 go?
Quadrant 2.
Quadrant 2. We always measure how far we are from the
X-axis.
x-axis. From 135 to 180, you're how far away?
45.
45. 45 is called a reference angle. The reference angle are the ones who've used that word other days. That's how far we are from the x-axis. So then we just go to our chart. 45, looking for sine. So we go over there, 45, looking for sine.
Root 2 over 2.
Root 2 over 2. Consider which quadrant we're in. Is it positive?
Yes.
Yes, because we went to the S quadrant, so that is a positive answer. And that just got easier than what we did yesterday. I'll do some more with a question about that. If you don't need to draw the picture, don't draw the picture. You could just think through, 135 is close to 180 or 360. It's closer to 180. So subtract with 180, come up with 45. Maybe you don't even need the picture. 240. And when you do the quiz, I don't care if the numbers are on there. I'm just doing it to speed us up. 240 is in which quadrant?
T.
The T. That's closer to the 180 side of town. So subtract 240, 180, and come out with 60. And then just do cosine 60.
1/2.
It is a half, and is it positive or negative?
Negative.
It is negative because we're doing a cosine in tangents quadrant, so we're like trespassing in the wrong yard. Get off my lawn. You're negative on that. 330. Quadrant.
C.
C. Since it's a tangent problem going into cosine's yard,
It's negative.
it is negative. 330 is close to 360. Subtract the yield 30, and then grab tan 30 off the chart.
3 over 3.
Any question about those three? What's going to be a tiny bit harder on the next three? How are the next three going to be a baby bit harder? They're not on the chart, but they sort of are. We're going to have to do an extra little bit of a thing. We're going to have to flip them. So 210, quadrant, is the T. Is tangent anything to do with cosecant? No. So this will be negative. 210, is it closer to 360 or closer to 180? 180, so subtract the yield. 30. Who is cosecant's friend? Which of the big three is cosecant's friend? Sine. So take sine 30's answer, but flip it.
-2.
It is going to be a 2. Anybody first for?
How come for sine it's 16, 10 is 30?
We're going to figure out how far away we are from 180s. So 240 away from 180 is a difference of 60.
Okay. That's what we're using 180 or 360.
Always using 180 or 360 because we're still doing what we've been doing since Friday about the reference angles trying to touch to the x-axis, measuring to the x-axis. 300 quadrant
C.
C is cosine friends with secant.
Yep.
Yes, so this answer will be positive. 300's reference angle,
360.
using 360, subtract to get
60.
60. So we're going to go use secant's partner is cosine. Cosine 60, but flip.
2.
Sneaky trick, anything that ends in 5, which reference angle will it have to be? 45. Anything that ends in 5 is going to be a 45. You still have to think about, though, what quadrant you're in. 225 is in
T.
T. We're doing cotan in tan's backyard, positive. Tan 45, 1, but we should think about, since it's cotan versus tan, we should think about flipping, but flipping 1
It's just 1.
is still just 1. Question about concept? So let's take a peek at homework page, and then I'll do a couple for free, and then we'll go into homework answers. I am on still page 13. Today's going to spill more into 14. So I'm going to start with 28 has tan 120 plus cotan negative 30. 29 has tan 300 times secant 300. 38 has cosine squared 150 plus sine squared 150. 43 has secant 30 dividing cosine 30. So we're doing the same thing we were doing, it's just there's 2 or more problems within a larger problem. 120 quadrant
S.
S, so negative or positive,
Negative.
negative. Subtract to get rid of that and get a chart-worthy angle,
60.
60. Look it up,
Root 3.
root 3. Negative 30
C.
quadrant is C. How far is it from the
30.
x-axis? 30. Cotan 30.
Root 3 over 2.
Disagree.
Oh.
Root 3 over 3, but
Flipped.
flipped. Positive or negative?
Positive.
Negative. Why negative for this? What quadrant were we in?
C.
The C quadrant doing cotan,
Oh.
and those guys aren't present. So something that looks like that. I wouldn't do an immediate fix as you're working, but I'd wait till now-ish to fix things. Which of these can I make better?
No, second.
The second one,
3 root 3 over 3.
second.
3 root 3 over
3 root 3 over 3 is pretty good.
3. Negative.
Can you make that better?
Negative.
It is negative, agreed, but still can be better.
Negative root 3.
Just on root 3, because those are cancelable.
Oh.
Okay, and an interesting twist, flipping this will always make that, and likewise flipping that will always make this. So that can help speed up your process if you like. If negative root 3 adds another negative root 3, a thought on the grand total? If negative x added another negative x, what would you make? Negative 2x, because invisibly there are 1s. These likewise. So negative 1 root 3 and another negative 1 root 3 is negative 2 root 3 grand total. Three hundreds twice on this one is kind of handy. Those are both in whose quadrant?
C.
C. So tan would be
Root 3 over 2.
positive or negative. If we're in cosine's quadrant,
Negative.
tan is negative, while secant
Positive.
is positive. The 300s living in the cosine quadrant are how far from the x-axis, each of them?
60.
60s. So we want to do tan 60 straight from the chart,
Root 3.
root 3. We want to do secant 60 by using who on the chart?
Cosine.
Cosine, but
Flip it.
flip it
2.
is 2. Can we write that in a better way?
Negative 2 root 3.
Negative 2 root 3 again, 2 in a row. This one I'm happy for the squares. What's really nice about squaring anything ever? What happens when you square things, for sure. Come back to that. Let's go 150, what quadrant?
S.
S. How far is 150 from the x-axis in the S quadrant? It is 30 away. Why is squaring outstanding?
Get rid of the root.
That's true. What else does squaring get rid of? Somebody from calculus. Why is squaring great?
No negative.
Positives, no negatives. Negatives die. So it doesn't matter what's positive where in terms of the negative, positive stuff, because when you square, you're guaranteed a positive anyhow. Cosine of 30 from the chart,
Root 3 over 2.
root 3 over 2, which in a second I'm going to square it. Sine of 30 from the chart,
1 over 2.
it's 1 over 2, and I'm going to square that as well. What will I get when I square this?
3 over 4.
3 over 4. When you square a root, the root disappears, but when you square the 2, it turns into a 4. Square the half,
1 over 4.
it's a 4. Best answer
1.
is 1. 4/4. 30 are both nice, because 30 are both in quadrant 1, and who's positive there is all of them. So everything's positive, we don't have to worry about signs on this thing either. So cosine 30, let's just grab that one first.
Root 3 over 2.
Root 3 over 2. Secant 30, let's grab that one.
2 over root 3.
2 over root 3, and I would just let that sit like it is for a minute. I wouldn't immediate fix all of those roots on the bottom. I would just see if it'll fix itself. 7th grade math move, flip the second fraction. So this one is how it is. This one needs to go upside down for us to multiply. Top, 4, bottom, 3. And we didn't need to fix that immediately because it kind of just like self-fixed itself. Question about any of that stuff? We're same page, we're just working as high as 46, but using the chart. if you need to draw pictures to help you understand where you are and what's positive where, feel free. But if you just draw this once at the top of your paper, and draw this once at the top of your paper, that might be enough to not have to like draw much of anything else the rest of that one.